We all talk about artificial intelligence, but have you ever stopped to think about its physical cost? I mean, it's a lot more than just some servers humming away in a data center. It's having a huge, direct impact on our power grid, and maybe more importantly, on your wallet. So let's break down AI's hidden power play.
So, if you've glanced at your utility bill recently and felt a bit of a shock, you are definitely not alone. And the reason for it might not be what you think.
We're all trained to just blame inflation for every price hike we see, but this is something else entirely. We're talking about a fundamental shift in how our energy grid is priced.
The AI boom is creating this massive vertical shock to our power infrastructure, and that cost, it's being passed right on down to you. Really, you can think of it as a hidden tax, one you never, ever voted for.
And look, this isn't some abstract theory. In the Baltimore gas and electric zone, residential customers actually saw a 14% monthly increase on their bills. For businesses, it was even higher at 16%. This is a direct result of new data centers driving up wholesale electricity prices for everybody.
So, how in the world did we get here? Well, to understand this huge macro crisis, we have to start at the micro level. We're talking about a single AI query.
Okay, a standard Google search is incredibly efficient. It uses about 0.03 watt-hours of energy, barely anything. But a standard ChatGPT query, that eats up 0.34 watt-hours. That is a gigantic leap. We're talking more than a 10-fold increase in power for just one single request.
And that's just for a standard query. The cost scales brutally from there. Advanced reasoning models, they can burn through up to 40 watt-hours. That's over 1,300 times the energy of a simple Google search. And when we start talking about video generation, oh man, it's thousands of times more.
For decades, we kind of had a free lunch in the world of computing. It was this principle called Dinard's scaling. And it basically meant that as transistors got smaller and more powerful, their power density stayed the same. So you got more performance for the same power draw. It was amazing. But that principle died around 2006.
Yeah, we literally hit a wall of heat. Without Dinard's scaling, every new generation of AI chips demands more absolute power. More computation now means a linearly higher power bill. There's just no escaping the physics of it.
So, this has created a huge physical bottleneck. And it's not just that demand is passively going up. The tech giants see this coming, and they are making a preemptive move to lock in all the power for themselves.
This chart shows you their strategy in action. Just 4 companies, the tech giants we call hyperscalers, are buying up nearly half of all new corporate clean energy on the entire planet. They're using their massive balance sheets to effectively starve out the rest of the market.
I mean, just look at this deal. Microsoft is paying an estimated $115 per megawatt hour to restart a nuclear plant. The average market price is only around $50. So they're paying a 130% premium. Not for cheap power, but for guaranteed 24/7 power.
And Amazon's doing the exact same thing, buying a massive data center campus and locking in its power directly from the nuclear plant next door. The pattern couldn't be clearer. Secure, reliable, baseload generation, no matter the cost, and then wall it off from everybody else.
So, what happens when just a handful of trillion-dollar companies corner the market for reliable energy? Well, the rest of the economy ends up paying the price.
Heavy industries are the first to feel the pain. We're talking about companies that make physical things, steel, chemicals. They run on massive amounts of electricity and usually have pretty thin profit margins. That makes them extremely vulnerable to these price shocks. And they know it. This isn't just our analysis. This is straight from the steelmaker Nucor's own annual report. They are explicitly warning their investors that rising energy costs are a threat to their entire business model.
And this table here quantifies the bleeding. A 40% power price shock could erase almost 3% of Dow Chemical's core profit. For these companies, that is a massive hit. And they can't just pass that cost on to us because foreign competitors with cheaper energy will simply swoop in and take their market share.
But the final problem, it's the biggest one of all. It's not just about cost anymore. The physical grid itself is failing to keep up.
Get ready for this number, 2,600 gigawatts. That's the amount of power generation, mostly clean energy projects, that is stuck in regulatory queues, just waiting to be connected to the US grid. That's more than double the entire existing capacity of the country. It's just sitting there, waiting.
And the process is completely broken. A new power project enters the queue, then it waits an average of 5 years for a decision, and then 80% of the time, the project is just withdrawn. It's a systemic failure to build.
So let's bring this all back home. We've seen the physics, the corporate power plays, the damage to our industries, and the grid that's failing. What does it all add up to for you?
This is it. This is the projected cost that's going to be passed directly to U.S. homes and businesses between now and 2050. It's the direct financial consequence of AI's energy demand. Nearly $1 trillion added directly to your bills.
And that really leaves us with this final crucial point.
An AI query isn't just some digital abstraction. It is a physical event that burns fuel. The ultimate constraint on AI isn't going to be technology. It's the cost required to upgrade the entire global electrical grid, and whether we, the public, are willing to keep paying for it.